right, so this is just a small review that'll be very helpful for your quiz you're about to take, and it'll also be very helpful to look back at. You'll have another review too, but this will be helpful to look back at or to review now for your test next week. That's your district test, and it covers a little bit of everything we've done this 9 weeks. It's not hard, so we're just going to refresh over some of the basics. So we want to talk about parent functions. You have 6 different parent functions. The most basic one is our linear function, the equation y equals x. It's graphed like this, and a few things about it. It has no minimum or maximum. It does not have a vertex. It's just a straight line. And then your domain and range are both all real numbers, okay? So this is your linear parent function. We also have our quadratic parent function, which is the equation y equals x squared. It's that parabola, the U shape, okay? It does have a vertex, and it vertex crosses at the origin 0, 0, and the vertex is also a minimum because it's the lowest point, right? And then this one would have a domain that is all real numbers, and then the range is any y value greater than or equal to 0, okay? Then you have your cubic, which is the equation y equals x cubed, or x to the third power. X to the third power is the same thing as saying cubed. This one is kind of like a little swirly line almost, but it swirls right before it gets to the middle of the origin. So it does cross through our origin, but it does not have a minimum or a maximum, and it does not have a vertex, okay? This one, like the linear, which is a straight line, this is a swerved line, but its domain is also all real numbers, as well as the range is also all real numbers, okay? Our fourth one is the cube root function, which is y equals the cube root. So it has that little 3 above the little root part, the cube root of x. Or another way you can write it is x raised to the 1/3 power, okay? It looks a lot like the cubic one turned sideways. This is your cube root function graphed. Does not have a minimum or a maximum, no vertex, and it also has all real numbers for the domain and for the range, okay? All right, and then our last 2 parent functions, we have our square root parent function, which is y equals the square root of x. And it just starts at the origin and then goes outwards. So it's kind of like half of your cube root function. No minimum, no maximum, no vertex. Then we have our absolute value. Oh, another way you could write this is x raised to the 1/2 power, okay? And then we have our absolute value function, which is y equals the absolute value of x. It's that V shape, okay? It also has its vertex at 0, 0. So it's vertex at 0, 0, and it's also a minimum. And then the domain and range for the square root function. The domain is the only parent function where the domain is any x value greater than or equal to 0. And then your range is also any y value greater than or equal to 0. For your absolute value function, domain is all real numbers. And then your range is any y value greater than or equal to 0. Okay, transformations. So this is kind of how I have each little part of your equation labeled. This would be a good thing to take notes on if you need help with transformations. Just pause the YouTube video and you can write some of this down. So y equals, and then you may have a positive number here, it may be a negative. If it's positive, nothing changes. It's just normal. If it's negative there, then that's gonna cause your function to reflect across the x-axis. So if it's that U shape, it's gonna reflect and it's now gonna flip downwards, right? And then if that value, so not including the negative or the positive, whatever, just that number in general, if it's greater than 1, it's a vertical stretch. If it's less than 1, it's a vertical compression, okay? So doesn't matter about negative or positive. If it's a whole number, or if it's a number like 2 or 5, those are both greater than 1, so it's a vertical stretch. If it's less than 1, meaning you have a fraction like 1/2 or 3/5, something like that, this would be a vertical compression. Inside of the absolute value signs, the parentheses, square root, whatever it is, whatever number is being added or subtracted to the x either shifts it left or right. If you're adding to your x, it's left. If you're subtracting from your x, it moves right. And then the number out here that's not grouped with your x in any way, so it's not under a square root or a cube root or parentheses, absolute value, whatever. If it's being added, then it shifts your graph up. If it's being subtracted, it shifts it down. So this negative, right, is going to transform our parent function. So this is our absolute value parent function. And then the negative that's here but not here, right? So that's going to cause it to reflect over the x-axis. Okay. Then just looking at the 3, I don't care about this negative. This 3 is greater than 1. So since 3 is greater than 1, it's going to be a vertical stretch. Okay, which means my graph is going to stretch taller vertically. Then this -5 that's grouped with my x, this is going to shift my graph horizontally to the right, 5, okay? And then the -6 on the end is like our k. We're subtracting, so it's going to shift it vertically down 6. And that's it. Okay, one more quick example. This 1/2 out front, it's less than 1. So this would be a vertical compression. Okay, meaning whatever shape our graph is, it's being compressed shorter vertically. +3, it's grouped with my x. So this is, we are going to shift horizontally to the left. And you can see that it's squared, which just means that your parent function is the quadratic function, y equals x squared. Okay, for inverses, you could have a function that looks like this or this, fractions, no fractions, either one. So your first step is always to replace f of x with y. So we have y equals 1/2 x plus 5. Step 2 is to switch the x and the y. So I'd have x equals a 1/2 y plus 5. And then step 3 is just to solve to get y by itself. So to do that, we would subtract both sides by 5. X minus 5 just stays as x minus 5 because they are not like terms. And then the opposite of multiplying by 1/2 would just be to multiply by that fraction flipped, which is 2/1, or just 2, right? So these cancel, which means we get y equals 2 times x minus 5. Or we could rewrite this and distribute that 2 that's being multiplied out front and have y equals 2x minus 10. Either way you see this, both are correct, okay? And then we have this one down here. Okay, for this one down here, same steps. So we're gonna say y equals 5x minus 1. We're gonna switch our x and our y. And then we're gonna solve to get y by itself. So we have x plus 1 equals a 5y. Divide both sides by 5. And you get y equals, you could leave it like this. This is perfectly fine way to write the answer. Or you could split it up. And you would have, there's a 1 in front of that x. So we would have a 1/5 x, right? If I look at just this, I have 1/5 plus, and then I look at it 5 underneath this number. So I'd have plus a 1/5 equals y. Also a perfectly fine way to write this. Okay, so Mary spent $90 on things for her dog. She bought $3 treats, $5 toys, and $6 outfits. She bought 2 more treats than toys, and she bought 18 items total. How many did she buy of each item? Okay, so let's look at her totals. We know she spent a total of $90. Okay, Another total we have is she bought 18 items total. We don't have another total, but we have a comparison. She bought 2 more treats than toys. Okay, so treats is greater. She bought 2 more treats than toys. Let's pretend, obviously she bought 18 items total, so we're pretending here. If she bought 20 treats, okay, so she bought 2 more treats than toys. So she has 2 more of these treats than she does toys, which would mean she would have 18 toys, right? Well, 20 and 18 are not equal, so if I wanted to make them equal each other, I would have to add 2 more toys, right? Add 2 to 18. So that's what our equation is going to look like. Okay, 20 is equal to 18 plus 2. So the amount of treats that she purchased is equal to the amount of toys that she purchased if you added 2 to it. Okay, if you don't add 2, then they're not actually equal. But if you add 2 to the number of toys that she purchased, then it would be the same amount as treats that she purchased. Okay, so then our variables. Since we have treats and toys, T and T, we'll just use X, Y, and Z. Okay, so X would be our treats, Y would be our toys, and Z would be our outfits. Okay, and then we want to do our equations. So we're doing our money here. To add up to $90, we have $3 times the amount of treats that we purchased. We have $5 times the amount of toys that we purchased. And we have $6 times the amount of outfits that we purchased to total up to $90. And then 18 items in total, so she bought some number of treats plus some number of toys plus some number of outfits to total 18 items. And then we would say treats equals toys plus 2. And that's a 2 and not a Z. Okay, so from here, if I wanted to figure out the exact number, I could put this in the matrix, right? But to put this in the matrix, I have to solve this last equation first, okay? Because I like how these above are X column, Y column, Z column, and then it equals your total, your number without a variable, right? Here we have X equals a Y plus our number without a variable. So we need to move this Y to the other side. So I'm going to take that X equals Y plus 2. And I need Y to move to the other side, which means it's going to change signs because you're subtracting it. So we have X minus a Y equals 2. Now I don't have a Z, but it's okay. We can put a 0 for Z, but where our X's are lined up, our Y's are lined up, and then it's equal to our number without a variable. Okay, so these would be our 3 equations that we're going to plug into our matrix, right? So we're going to have a 3 by 4 matrix. So I have 3 X's, 5 Y's, 6 Z's equals a 90. And that's not negative, that's just me listing out these are my 3 equations I'm using to put in the matrix. And then I have 1 X, 1 Y, 1 Z, and it equals 18. And then I have 1 X, negative 1 Y's, 0 Z's, and it equals 2. Okay, and then let's plug it in our matrix. All right, so into desmos.com/matrix, and we're gonna do new matrix, and we want to have 3 rows and 4 columns, and then we'll put our numbers in. So $3 for dog treats, $5 for dog toys, $6 for outfits, so we spent $90. Then 1 X, 1 Y, 1 Z for a total of 18 items, and then we had 1, negative 1, 0, and 2. So we hit enter, and then we hit RREF, and this is for matrix A. So we have 5, 3, and 10. We know these are answers because we have those diagonal ones. Everything else are zeros, right? So that would be my answer. So that means we bought 5 dog treats, 3 dog toys, and then 7 outfits. Oh, why did I say 7? 10 outfits. 5 treats, 3 toys, and 10 outfits. Ooh, that's a lot of outfits for a dog. And there we go.